Hello everybody. So in this video I'll try to solve another real life math from exercise 4.2. This is 56 number math. If you want to see it, this 56 number, this one we will try to solve. 50 population model. This question is called population model. So I hope you have the worksheet, so I'll just start solving it. I also have the worksheet, so I'll solve it from here. Okay, this is question number 56 number question and exercise number 4.2, as you know, Michael Sullivan book, and 9th edition. This one is, the question is a rare species blah blah blah. So the function is given in terms of t is the number of months. So some function is given like 50 into 1 plus 0.5 of t divided by 2 plus 0.01 into t. So this is the function given, the populations, that function. A rare species of insect, this is the question. A rare species of insect was discovered in Amazon rainforest. To protect the species, environmentalists declared the insect endangered and transplanted the insect into a protected area. Then the population P of the insect T months after being transplanted is this. Now a number. How many insects were discovered? In other words, what was the population when t equal to 0? So when t equal to 0, a number question we are starting now. They said when t equals to 0, what was the population? So we will write 0 here, and we will write 51 plus 0.5 into t equal to 0. So 0 there, then 2 plus 0.01 into 0. So you see, 0 into 0, this term will become 0, this term will also become 0, only this 1 will be remaining and this 2 will be remaining with this 50. So 50 into 1 equals to 50 divided by this 2. So answer is 25. So that means 25 is the number of insects at the beginning. Now B number question is, what is the population, what will be the population after 5 years? So that is the question. What will the population be after 5 years? This is the B number question. So in 5 years, this t is actually month. They said it in the question. This t is actually month. So but now they are saying in 5 years. So that means 5 years equals to how many months? 5 years. 1 year means 12 months. So 5 years means 5 into 12 equals to 60 months. 60 months. So this is the amount of months. Now we will put it here in the function. P of 60 equals to 51 plus 0.5 into 60 divided by 2 plus 0.01 into 60. So let's do the calculation. Most probably answer will come 596 something. Let's do it. 50, okay, let's give a bracket 50, then bracket start 1 plus 0.5 into 60, bracket close, again bracket close because I gave 2 bracket start 2 plus 0.01 plus into 60, bracket close, equals to 596.15. so that's the answer. Answer will be 596. We do not have to write the decimal because insects cannot be decimal, that's why we have to round it off. And then the next question is, they said C number, determine the horizontal asymptote of P of t. What does the largest population that the protected area can sustain? This is their question. So C number, now I'll try C number. C number is very interesting here in this paper. So C number, their question is, what is the horizontal asymptote of this? So how do we find horizontal asymptote? We look at the actually variable. So this variable in this question is t. There is no x here. So t, this function is defined in terms of t. So t is the variable. You see, what is the power of t here? Power of t is 1. Power of t is what? 1. So when power is same, asymptote will come from the coefficient. So coefficient here is 0.5, but it is into, see, into, so that means 50 into 0.5 we have to write. Then this is 0.01, this is fine, but here we have to multiply. So basically if we multiply it, and then our horizontal asymptote in this case will be p equals to, let me write it, horizontal asymptote will be p equals to this 50 into 0.5, 50 into 0.5 divided by 0.01 divided by 0.01. Just the number, we have to just take the number from the t, because the rules is if the power is same, then the coefficient will give the horizontal asymptote. So the coefficient here is 0.5, but what, there is a number multiplied, see, this is the bracket, so I have to multiply with this and this. Now this number is out because this is separate number, we have to just look at the coefficient of t. So t's coefficient is 50 into this, so this is how we get it. Therefore p equals to, if you do the calculation, I suppose this will be 2500. Let me recheck it. 50 into 0.5 divided by 0.01, 2500. So this is the horizontal asymptote of this function. Now what does it mean? Actually, there is another question. That question is, what is the largest number of population that the protected area can sustain? Now as you see, as this is the asymptote, this is our asymptote, this is our horizontal asymptote. So basically if the number of population increases, or we can see it like in terms of t also, if the time increases, that as the time goes up and up and up, our function will go closer and closer to this number. Our function will go closer and closer to this number, because when the function increases or decreases, whatever it is, this will go closer and closer to the asymptote, I mean in that direction. So basically this 2500, this will be the, so this 2500 is the largest number of population, number of insects that blah blah blah, that you see, this is written in the question, that the protected area can sustain. So this is the answer. 2500 is the largest number of insects that the protected area can, oh they said population, not insects, but the question is in terms, question is actually insects, so population means insects here. Anyway, so 2500 is the largest number. Why? This is the asymptote, because if one value goes up and up and up, then actually the value actually go closer and closer to this value. Why it is p? Why we are writing p here? Because if you look at the graph of this function, this direction is actually t, time, because this question is given in terms of, and this direction is actually p, okay, p, population, and horizontal asymptote will be somewhat here, 2500. Suppose it is 2500, so horizontal asymptote, this is the horizontal asymptote of this question. So if you draw the graph, then if t increases, the graph will go closer and closer to that line. That's the point, and that's why we said p equals to 2500 horizontal asymptote. Normally we say y equals to, but in this question it is p. That's why we are not saying y equals to, we are saying p equals to. I mean, this actually always depends on how we define the function. The graph actually comes from there. Anyway, I hope it worked. I hope it helps to understand and visualize the picture of this question. Thank you very much. Bye bye.